Hey guys, thank you for checking out this video. My name is George. In this video, we will learn how to use a color touch sensor with ESP32 using MicroPython programming language. Color touch sensor is a touch sensor module with an added indicator to indicate the state of the touch sensor. As you can see here, this is red, green, blue, and rainbow. What I have here are color touch sensor from Gorilla Cell ESP32 development kit. It comes with 4 pieces, which are red, green, blue, and rainbow, which changes colors while it is still on. It has 3 pins, namely G for the ground pin, V for the supply voltage, and S for the signal pin. For this experiment, you will need an ESP32 development board which will serve as the brain, an ESP32 shield from Gorilla Cell to extend the ESP32 pins to pin headers for easy circuit connection, a 3-pin female to female DuPont jumper wires, and of course, the color touch sensor itself. I already have it set up in advance where the ESP32 is attached on top of the ESP32 shield. I also attached the color touch sensor with the DuPont wires by following a color coding, which is black for the ground pin, red for the VCC, and yellow for the signal pin. Then the other end of the DuPont jumper wires is attached on the ESP32 shield by matching the colors of the DuPont wires to the colors of the pin headers, which is black to black, red to red, and yellow to yellow. For this, I choose GPIO 32, 33, 34, and 35 as signal pin from the red, green, blue, and rainbow color touch sensor respectively. Now for the software part, I prepared here 5 example source code for this demonstration. For example number 1, we will just explore the basics of reading the color touch sensor, and for simplicity, we will just use the red color touch sensor module. Let me disable all the touch sensor. And let me click the run current script to execute example number 1. Now to read the current state of the pin for the color touch sensor, just send cts.value, open and close parentheses, and hit enter. And the current value is logic 0. Let me prepare the cts.value again. Then let me activate the red color touch sensor and hit enter. And as you can see, the current state of the pin associated to CTS is currently logic 1. Notice also that if we press the color touch sensor, the background color will also light up as an indicator. By the way, this is a rainbow color touch sensor because it changes its colors by following the rainbow color, which is the RGB, or red, orange, yellow, green, blue, indigo, and violet. Then it will reverse the color changes back to red color. Now let me disable all the color touch sensor. And let me select example number 2 and click the run current script. And if I press the red color touch sensor, it will display a red color touch sensor is activated. If the red color is currently active, meaning it has a background color, it will not do anything. Of course, all other color touch sensor has the same function. This is achieved by checking if the specific color touch sensor is currently active or have a value of 1. If it is, then check if the flag is currently false. It is set to false only when the color touch sensor goes to inactive or logic 0 as the opposite of this if statement. In this way, we can prevent multiple execution of the program. Let me test all the other touch sensor. This is green, and as you can see also here, green color touch sensor is activated. Let me press the blue color touch sensor and also the rainbow. Let me click the stop button to terminate example number 2. Now, with example number 3, let me introduce the hardware interrupt as an alternative option in handling GPIO pins. Interrupt is a great way to detect fast changes in the state of a certain microcontroller pins. For this, we will only use the red color touch sensor for simplicity. Let me click the Run button to execute example number 3. So you will have a better idea when I explain later on. Now when I press the red color, nothing happens. Even the green, blue, and the rainbow. Because it is waiting for rising edge, which is the changes from logic 0, which is currently now, all touch sensor are currently inactive or in logic 0. Now when I press the red color, it will print a message in the REPL saying LED is toggled. To create a pin interrupt, we still create the pin object, just like this. Then we created the interrupt by using the object name, redCTS, this is the one we created here, .IRQ. Then in the parameters, we set the trigger to the trigger edge we want to use. So we can use the rising edge or the falling edge or both to detect the rising edge and the falling edge. By the way, rising edge detects signal change from logic low to logic high, while falling edge detects signal change from logic high to logic low. Currently, we are using the rising edge, hence it only detects the change from inactive state to active state. In the handler, we set the callback function that will be called when the interrupt happens. In our case, we call the handle_interrupt function. And if the handle_interrupt function is called, we just toggle the onboard LED here, and we print LED is toggled in the REPL. Let me press again the red color touch sensor. Nothing happens. But when I press again, LED is toggled, and as you can see, the onboard LED is also turned off. Try again to turn on the onboard LED. Now let me click the stop button, and let's use both trigger edge for our interrupt. Let me click the save button and click the run current script, so that any press in the color touch sensor will toggle the onboard LED and will also print the LED is toggled. Now LED is toggled. When I press again, LED is toggled. LED is toggled. LED is toggled. Let me click the stop button to terminate example number 3. Let us see example number 4. Let me click the run current script to execute example number 4. Now, when I press any of the color touch sensor, it will print the specific pin where the pin interrupt is coming from. Let me deactivate the red color, and as you can see, pin 32 is displayed in the REPL. I will touch the green color, pin 33, pin 34, and pin 35, because we are using both trigger edge for the interrupt. Let me click the stop button to terminate example number 4. By the way, we are using a single callback function, which is the HandleInterrupt, as the callback function for all the interrupt we created. Now, for the last example, what if we want to have the value that is 32, 33, 34, and 35 only? And we extract that value. We remove this pin and the open and close parentheses. Let me select example number 5. Let me click the Run Current Script button. When I press any of the color touch sensor, it will tell what color touch sensor is activated. Let me deactivate all first. Now, if I press the red color touch sensor, it will tell that the red color touch sensor is triggered. If I press the blue color touch sensor, it will tell that the blue color touch sensor is triggered. And same as with the other touch sensor. This is achieved by checking if the press variable is true and if the specific pins are triggered, which are 32, 33, 34, and 35. If yes, then the specific message is printed in the REPL. Any of the pin interrupt will call the HandleInterrupt by passing the pin information. And if the interrupt callback function is called, it will set the global press variable to true, meaning that an interrupt has just happened. And it will also set the global IRQ underscore pin as the source of the pin interrupt. This is achieved by slicing the string, removing the pin string, and the open and close parenthesis symbol, which is explained here. So I think that's pretty much of it. I hope you've learned something from this. If you have any question, please do not hesitate to write your message in the comment box provided. And if you enjoyed this video, please do like and share so that it can reach more people who might benefit from this. Please don't forget to subscribe and turn on the notification bell because I will be uploading more videos like this in the future. Thank you and see you next time. God bless!